This is the force velocity curve. This curve states that the force of any type of muscle contraction is affected by the speed at which that contraction takes place. Now, this relationship between force and velocity is different for different types of contraction, and therefore the curve is different for concentric contraction, the curve is different for isometric contraction, and the curve is different for eccentric contraction. So starting with the first part of the curve, that is concentric contraction. So now for concentric contraction, whenever the velocity decreases, that is when we move towards the left side, the force with which the contraction occurs increases. For example, if I am flexing my elbow, so this movement is concentric contraction. Elbow flexors are contracting concentrically against gravity. So according to this part of the curve, if I decrease the speed at which the contraction takes place, the force required to maintain this contraction will increase. So this is what is understood by the first part of the curve. If the velocity with which the contraction is occurring decreases, the force required to maintain this contraction increases. So this is the relationship between velocity and concentric contraction. Next is isometric contraction. Now isometric contraction is shown at zero velocity. Why is it so? Because in isometric contraction, no movement takes place and speed is equal to distance upon time. When no movement takes place, no distance is being covered. So the distance covered over here is zero. So the speed and velocity is going to be zero. That is the reason why isometric contraction is shown at zero. Now if you observe, the force required to produce an isometric contraction is more than that required for concentric contraction. So if I am contracting the elbow flexors isometrically, in this position, the force that will be required to maintain this contraction will be more than this movement. So force required to maintain an isometric contraction is more than that for concentric contraction. Then moving to the third part of the curve, which is for eccentric contraction. Now for eccentric contraction, the relationship is as follows. If the velocity increases, that is when I move towards the left side of the curve, then the force required initially is going to increase and then it plateaus. So if the velocity increases, the force required initially increases and then it plateaus. So if I am contracting the elbow flexors eccentrically, this is the movement, elbow flexion towards gravity. So if I increase the velocity at which the speed occurs, initially the force required will increase and then it plateaus. So this is the force velocity relationship for three types of contraction. Now why is it important for us to know this? So that we can alter our rehabilitation accordingly. There is something known as velocity specific training. So depending upon the type of condition and the type of the patients and the demands of the patients, you decide what type of muscle contraction needs to be given and at what speed. And that is the reason why you need to understand this curve.